Module 7, title of this module is Morphological Processing. So again, I am going to discuss some of the technicalities involved in morphological processing. And this is a very high level computation which can be done automatically with sufficient knowledge base retrieved from the analysis of language, and our goal is to develop a morphological analyzer for a language so that this tool can be utilized for various activities of language applications and uses, starting from classroom teaching to machine learning. So in this module, we will try to describe the basic issues involved in morphological processing. Also, before that, we should try to define what morphological processing is, the methods of information storage, methods of processing, how to process inflected words, non-inflected words, and outcome of the processing. So, as we have already identified, what is a morphological processing? The morphological processing, in simple sense, identifies a word, breaks it into different morphemes, and also identifies the syntactic, semantic, or lexical identities of those components which are combined together, and tries to compose the meaning of the word. Suppose we have got an inflected form. We know that the word an inflected form is generated or produced by combining the base form or stem or an inflection. So we know it very well. The machine has to do the same thing. It has to identify that if an inflected form is given, it will identify, break into two parts, the base part and inflection part. Also, if possible, there is multiple inflections combined together as a string, it's also break into different parts. And so that how these components are coupled together, joined together to generate the form inflection, and it is tagged with the base part. So this is very much required to decompose the words, to understand the words, how they are composed, how they are constructed. In an inflectional language like Bangla or many other Indian languages, where we know that particularly a inflected form is generated by way of adding inflections, we need to know what kinds of inflections are combined together, if the addition of inflection has changed the structure or form and meaning of the word, and what kind of new additional knowledge is generated out of it, how that can be applied in other cases, other application fields. So, a lot of important issues are important to it. So, morphological analyzer is an independent natural language processing tool. The interface is something like that. There is a tool is there, you provide a word, it breaks into parts and provides you a whole load of information related to the word. In the reverse way, what also can do, you can have a morphological generator. If you provide a whole set of base forms and a set of inflections, it can generate a form, fully inflected one or a new form. So this is the reverse process of morphological analysis, is a morphological generation. So if one end we can have a morphological analyzer, in the reverse way we can also develop a morphological generator. So it is better to reflect on some early works so far developed in morphological analyzer and morphological generator. So we know that many languages, almost English, French, Germany, Spanish, many languages has developed morphological analyzer and morphological generator. So say from early 1980 or something like that, many researches have been carried out in English and other languages to develop the morphological analyzer and morphological processor or morphological generator. Now we can refer to the Koskonini's model, the Kimo school, Wittenberg's Kartunen's model, and many other. Church and Gale have worked, and recently we can have come across many other models and theories to how to do the morphological analysis or our morphological generations. So after the introductions of language corpora, we have found large number of words that lexical databases are generated, and morphological analyzer and splitter or processor are already developed. But for Indian languages, it is not so promising thing. We have come across in several articles and journals that people have developed good morphological analyzers for many of the advanced Indian languages, particularly for Hindi, Bangla, Odia, Marathi, Telugu, Tamil, and Malayalam, and Marathi, and some other Gujarati and Konkani language also. People claim that they have developed good morphological analyzers as a part of a supporting tool for machine translation or as an independent tool for morphological language processing. So there are now some tools, some processors available for some of the languages in Indian languages among Indian language corpora. Although their success rate or the applicability of those morphological analyzers across Indian languages or in different languages is not yet challenged or verified and attested confirmed way, but still there are certain morphological analyses available for many or not many, some of the Indian languages, which is a good sign, and that knowledge base is required for developing almost similar tools for other Indian languages. Now we come across the basic issues, major issues involved in morphological analyzer development. So what happens that we have noted that in cases of to construct words, what we need, let us look at that. If we want to construct a word, what are the things we need? Now at one end we need roots or stems which have independent use in and a meaning in the text. That is also available. So either we can use those forms as independent words in the language. At the same time, we can add some additional information with that, which is called word formative elements like affixes, which we normally tag with roots and stems for providing new linguistic perspectives to the existing words. So these two things are always have to be taken into consideration while developing or doing morphological analysis. Invariably, there would be a set which is known as a root or stems. In another way, there would be a set of suffixes. Then, after a structural analysis of words collected from the corpus language database, it is found that words are generally formed as a result of several processes. When we look at the inflected words which are available in the corpus, we find there is at least 4 or 5 elements that are combined together. Conjoining between a stem and an affix, that is in one area, which is quite frequent in word formation. Conjoining between an affix and a stem also. Conjoining of 2 or more affixes with stems, that is sometimes or quite often it is quite frequent in the language that it is not that all the time only one affix is tagged to the stem. You can find out several affixes are combined together and to be tagged to the stem. Conjoining between 2 stems to produce a compound stem, and further that compound stem is further added with some affixes as a combination, and some acceptable combinations between the first 3 processes. So analysis of the text or words collected from the corpus text shows that there are 5 or 6 models or processes are actually working on it. So in word formation processes, morphemes are usually governed by the following 2 or 3 set of rules. To be more precise, 2 rules of morphosyntax, which works to restrict the process of random conjoining among the various morpheme subclasses. That is a very crucial issue. We have noted that there are some kind of restrictions applied in constructions of the inflected forms. You will hardly find out examples that the verbal suffixes are actually tagged with nouns until and unless you do it specifically in a certain purposes. In the reverse way, the suffixes or the inflections which are normally tagged with nouns hardly come with verbs. and that too in a rare cases. So you will never find that an indeclinable is carrying a nominal suffix. So what we want to emphasize here is that the combinations of those suffixes with stems or roots is highly rule-based, rule-governed, specified, constraints are there. So it is not an arbitrarily anything can come with any root and suffix, any suffix can come with any root, or the order of use of those suffixes is also not arbitrary. They come in a very sequential order. It is not that you can put one suffix or the other with a stem in a random manner. This never happens. So there are large number of constraints normally used in constructions of words. Rules of generative morphology also, which are concerned with the morphophonemic or morphographemic structuring of symbols at the boundaries of the T-conjugate morphemes. So there are also generative morphology rules which also work at the time of conjoining. So you know that when the two suffix, one suffix and stem is combining, you can get a new structure which was no more available inside the combining members. So that kind of there is a generative aspects also embedded into it. So these things are have to be taken into consideration at the time of morphological analysis. So in case of morphological analysis, for instance, if I say a finite verb for us is nothing but an isolated word where there is a root which is systematically followed by an aspect marker, an auxiliary marker, tense marker, person marker and particle, all arranged in a grammatically following a sequence of their uses applicable in a particular language. If you refer to that example here given in the table 1, suppose I am giving a Bangla example, surface from the word bolei chilam. This is a complete full-fledged verb form. So what you find if you do the work of morphological analysis of the word, what we'll get first, we'll get a root part, it's called bol, and the suffix part is eichilam. So this broadly first part, the bol and root part is eichilam. These are two parts which is identified by a morphological analyzer. Then further analysis of the text or the suffix part says that it constitutes an aspect marker as a, an auxiliary marker cha, a tense marker illa, a person marker am, a number marker 0, honorific marker null, or particle marker is e emphatic, which is embedded with suffix part. And the meaning of this we had already said, and parts of speech is a divided verb. So what we did that we decomposed the verb into different parts and identified what are the morphology or morphemes are combined together and how it is carried out and what are the informations are combined together and how this analysis is being done. So now when we think that the entire process can be done automatically by way of developing a system, we need to build up the system in such a way that this task can be successfully carried out. So to build up the process, we need a process called information storage. So in cases of information storage, first we do that we first collect a large amount of words, both of inflected form and non-inflected form, and we do an analysis manually to train the system, to update or to generate our knowledge base or lexical database or information that is required for the morphological analyzer. So we need an electronic dictionary or machine readable dictionary that is understandable, that is usable by the system. And this machine readable dictionary has two parts. One is called the root part or the root lexicon, another is a suffix lexicon. So what we understand that while we are developing the resources of the system, we need to have an electronic dictionary which contains a root lexicon as well as a suffix lexicon. The root lexicon contains the normal and allophonic variants of verb roots, noun stems, pronominal bases, adjective stems, adverb stems, postpositions and indeclinables in their lemmatized form. So the root lexicon will contain those information material in a systematic order in different classes with broad head under several major categories. While the suffix lexicon contains the total list of suffixes and all its possible morphophonemic variants available in the language. So if you look at the table number 2, figure number 1, electronic dictionary, which says that you can have in the root lexicon part several subdivisions, each one containing the root part of words belonging to different parts of speech. Say root lexicon 1, part 1 can have the noun nominal stem, part 2 can have pronominal bases, part 3 can be verb roots, part 4 can have adverbial stems, part 5 can have adjectival stems, or part 6 can be indeclinable, and part 7 can postpositions. On the contrary, we can have the suffix lexicon that is also matched in that way, so that suffix lexicon part 1 only contains the nominal suffixes. Suffix lexicon part 2 can contain the pronominal suffixes, and suffix lexicon 3 can have verbal suffixes. Suffix lexicon part 4 can have adjectival suffixes or adverbial suffixes in suffix lexicon 5. So this makes us a whole process of quite simplified to understand that what kind of root lexicon should match what kind of suffix lexicon. So this mathematical programmed strategy gives far better access for us, so that there is less complexities and we hardly allow that if overlap among those groups, subgroups can be permitted. So we know that root lexicon 1 actually contains noun stems, and suffix lexicon 1 also contains the suffix nominal suffixes. So when we are going to concatenate between a noun and a suffix, concatenate a nominal stem and nominal suffix, or when we are going to decompose or analyze a noun, we refer to only noun lexicon and a suffix lexicon, nominal suffix lexicon rather than others. So at the initial training phase, both RL and suffix lexicon compiled mostly manually as a training purpose in a highly sequential order following the stages, several stages. So at the initial training phase, both the root lexicon and the suffix lexicons are normally compiled manually in a highly sequential, precise, systematic order, and at that time the following stages naturally followed. All types of words, both inflected, non-inflected, compounded, compiled from corpora and sorted out in alphabetical order to generate a list of lexemes or lexicon, where all the repetitive forms are allowed to have only single entry by a process of tokenization. Then all sorted words are classified based on their parts of speech. Information is collected from the regular standard dictionaries as well as the post-tract corpus. So words are then arranged based on their parts of speech. Classified words are further subdivided into broad groups. One is called inflected group, another is non-inflected set. Then all non-inflected words which has nothing to decompose are put into the list of the particular parts they belong to, particular parts of speech. So if you from the corpus if you get say 100 words which are non-inflected, there is nothing to be tagged there, nothing is tagged there, no inflection. So those words are identified and sub-classified according to their parts of speech and already put into the root lexicons. Inflected words are first broken into root and suffix part. While roots are distributed within RL or root lexicon based on their primary parts of speech, the suffixes are further classified and stored within respective list of suffix lexicon based on the family affiliation to the particular parts of speech. So this is another stage where inflected words are broken for a training part. The some representative samples of all types of words belonging to different parts of speech are taken for initial manual analysis to find out the rules of grammatical mapping also. So you also need to identify the grammatical mapping rules that actually operate under the concatenation between root and suffix part for the generation part. So scheme is now made ready to identify the relevant suffix parts, number, gender, tense, aspect, honorific, etc. that are required for particular root or lexicon or stem to generate the valid surface forms. Then identifiable grammatical mapping rules are converted into algorithms for designing a system that can identify words processed rightly. So this is how the works. So here, if you look into the figure 2, you can get some idea how the introductory preparations of morphological processing is done. So first, to sum up, we take a language corpus, then generate a generation of lexicon database, classifications of words based on their parts of speech, then divisions of words into inflected and non-inflected words, then separation of root and suffix from the inflected words, generation of root and suffix lexicon, then morphological analysis of words, identification of morphological patterns, formation of morphological mapping algorithms. This part then goes to the part of the machine learning, where machine is trained gradually. If you look at the figure 3 here, you can also get some clear idea how data of different types are actually stored into the machine in a very systematic, synchronized manner, so that machine learning part or algorithm generation part is more simplified one. Also, we provide a set of rules, morphological rules or grammatical rules, based on which machine can work out. So this is the preparatory stage. Now the actual process of morphological analysis starts. What the machine gets a large list of words arranged in alphabetical order or in a random corpus in a text format. So given a sentence is full-fledged sentence is given to the system. What it does, it has to do processing, morphological processing. A search for a word begins from left-hand direction of the sentence, and it proceeds gradually towards the right-hand terminal point to the end of the sentence. So machine, what it does, first encounters a string, unbroken string, and identifies its existing words. That string is made with several characters, and proceeds further until it finds a blank space which indicates that it is the end of the sentence. Then what happens, once it identifies a word string, it goes back to the electronic dictionary, machine readable dictionary, which is already developed, and it follows the algorithm or the schema proposed in the following diagram, figure number 4. What it does here, now search out its root part, its match in the root lexicon. It breaks into 2 parts and search out, takes its valid output, takes it as a valid input for the dictionary. So when it searches in the root lexicon, it does 2 things: identify word as a sentence, takes it as a valid input part, then search for its root lexicon starts. It can go do it. If a match is found in using the electronic dictionary part 1 root lexicon, it produces the morphological details, because we have already noted that word can be the string which it identifies can be an inflected one or a non-inflected one. If it is a non-inflected one, its work is more simplified, because it immediately searches the whole string into the root list, base list based on different parts of speech, and it finds a complete match. Its task is over. It immediately produces, okay, this word is a noun, or this is a non-compositional composite unit. It cannot be broken, and it's a stem or a root, and accordingly with a parts of speech it comes out. But if it is an inflectional one, then it has to go for. If it finds there is no match found into the root lexicon of the word, it goes for follow the method of processing that we generally apply for inflected words. So first search part is carried out, identify whether the word is an inflected one or a non-inflected one. So morphological information first machine will provide us that this word is an inflected one or a non-inflected one. If there is a non-inflected one, it stops here. If it is an inflected one, it proceeds further. In cases of inflected words, it has a long part. First, identifies an inflected word from the corpus. Then, separates root and suffix part, referring to the root lexicon and suffix lexicon stored in the electronic dictionary one. The machine electronic dictionary, which is a machine dictionary, based on the knowledge, based on the data, based on the information provided, that it separates the root part and the suffix part of the word. Then it does the morphological analysis, again using information already stored in electronic dictionary to a second part of the dictionary, where detailed information of all the suffixes are already stored there. Then it tries to generate the output, resultant output, based with the information extracted from the other parts, and then the output is validated with the existing dictionaries or inbuilt dictionaries. So this schema figure 5 actually shows how the morphological processing of an inflected word is done. So the most important task is here the suffix stripping part. How to strip a sound? We have given here a table of algorithm which is in 7 different stages, how the process of suffix part can be stripped from an inflected form automatically with reference to the lexical or suffix database generated into it. So we can, in an algorithmic way, we can identify the 12 different stages. It is something like that. Constitute a substring combining first characters of a string. Verify if the substring matches with the substring of a string stored in a root lexicon. If a match is found, consider it as root and other parts as a suffix. If no match is found, then one more character add to the string. Repeat the same process as repeated in stage 1 and stage 2. Match the suffix part with the suffix stored in the suffix lexicon. If a match is found, consider the word is a valid one. Then apply the grammatical mapping rule of the root suffix combination. Match the output string with the input string for validation. Then produce the final, collect all grammatical and semantic information stored in the dictionary 2 and produce the final result. Encounter the next word string in the sentence. So there are 12 stages, one by one the machine has to repeat or follow to do the whole process of morphological analysis. So this is a very complex mathematical program. We need to be understood how machine works, and accordingly we have to define that program. So what is the outcome? Outcome of this tagging is that some words are rightly processed in the system, some words are wrongly processed, and some words not processed at all. So we can have, after implementation of the morphological processing scheme, we can have 3 types of results. Some words are appropriately, absolutely rightly processed because of the sufficient knowledge base already provided into the system in the form of a root lexicon or suffix lexicon or electronic dictionary or machine readable dictionary part 2. While some words are wrongly processed. There are instances, and it's quite a few instances in the corpus, tagged corpus, morphologically processed output, that we have noted that the words are not adequately, rightly processed because of some linguistic constraints. Mostly we have noted that we can have same set of suffixes both in cases of nouns and verbs. So machine, since either fails to identify to differentiate between those suffixes, it may happen that it can have double tag or double morphological analysis. This is an advantage also. If we find that there is the same set of suffixes used in cases of nouns and verbs, then a particularly inflected form can have 2 or more outputs showing at one point it is a noun, in another point is a verb. So we generally call that either it is at the word level it is in wrong process or ambiguous, or 2 or multiple processings. Third part is the morphological analysis, is that some words are not adequately tagged or not tagged at all. This generally happens if whenever we find there is a paucity of data provided in the root lexicon or paucity of data or information or algorithm provided to the suffix lexicon, and the algorithm database, or the digital database. So, three kinds of outputs are normally generated in morphological processing. So, in conclusion, we can tell that morphological processing is a very complex task, highly complicated. It needs lot of information at several layers, and it wants to work in a trial and error method to achieve a certain level of accuracy. And due to those complexities involved in inflectional languages, like most of the Indian languages, the robust, accurate morphological analyzer are yet to be developed for many of the Indian languages, keeping in mind that some of the tasks have already been done, but that target is not yet achieved. We need to develop more robust morphological analyzers so that all kinds of morphological information can easily be extracted automatically whenever some input is given to the system as a natural text. Thank you.